So today we're going to be looking at something called the empirical formula of a compound, and we want to keep in mind that the empirical formula is the simplest ratio of atoms present in a molecule. These should be, of course, whole numbers, because a formula doesn't just tell you what's in a compound. It tells you how many of each atom are in a compound. And since you can't have half of an atom, these all have to be whole numbers. The molecular formula is a little different. We'll get into what that is. But when we are attempting to calculate the empirical formula, all we care about is the simplest whole number ratio. Now let me give you an example of what it is that we're talking about, and I'll show you how we do this. So here's the type of question you can expect to be asked. We've got a compound that is completely unknown, but a little analysis shows its percent composition. It says it is 46.67% nitrogen, 6.7% hydrogen, 19.98% carbon, and 26.65% oxygen. What is the empirical formula? So we're going to follow a very simple set of rules here, and they rhyme so you can remember them a bit more easily. Check it out. So we're going to break this down into 4 steps. 1, percent to mass. 2, mass to mole. 3, divide by small. 4, multiply till whole. Here's what that means. Our first step is we're going to convert percent to mass. And it's really easy to do because we're just going to assume that our sample is exactly 100 grams. When you do that, when you assume that the sample is 100 grams, all of these percentages stop being percentages and they become masses. That means that now we have 46.67 grams of nitrogen, 6.7 grams of hydrogen, 19.98 grams of carbon, and 26.65 grams of oxygen. That's the first step. Now that we have these into masses, we can take the next step, which is we're going to convert all of these masses to moles. Because let's remember that if a formula is not only a ratio of atoms in a compound, then it's also the ratio of moles. Because if you have one atom in a molecule of a particular element, that means you've got 1 mole of that element in 1 mole of the compound. So let's take step 2, and that means we're going to convert these from masses to moles. We'll need the molar masses of each of these elements, and feel free to round as you see fit. So our next step is from mass to moles. So we've got 46.67 grams of nitrogen. Let's get that into moles. How many moles of nitrogen are 46.67 grams? From our periodic table and rounding to the nearest whole number, we know that 1 mole of nitrogen is 14 grams. Now, if we're rounding to the nearest whole number, that's going to create a couple of little difficulties, but we're just looking for close. So I'm going to say 46.67. I'm dividing by 14, and that means that I've got 3.33 moles of nitrogen. Let's keep the ball rolling. How many moles of hydrogen do we have? If we have 6.7 grams of hydrogen, and this one's easy because we know that the molar mass of hydrogen is 1 gram. So that's 6.7 moles of hydrogen. Let's do this with our carbon. And so we've got 19.98 grams of carbon. How many moles of carbon is that? 19.98 grams of carbon. We know that rounding to a whole number, 1 mole of carbon is 12 grams. Dividing by 12 gives us 1.66 moles of carbon. And let's do the last one. I'm going to adjust the size of my red pen here to fit. We've got 26.65 grams of oxygen. How many moles of oxygen is this? 26.65 grams of oxygen. And we know from our periodic table that the molar mass of oxygen is 16 grams. I wrote moles. 16 grams of oxygen in 1 mole. So 26.65 divided by 16 is 1.66 moles of oxygen. Well, these are clearly not whole numbers. And so the third step is to divide everything by the smallest number of moles, because what that will do is get the smallest ones to 1, and everything else should be a nice whole number. So in this case, the smallest is 1.66. So if I'm going to divide everything by 1.66, these are both 1. If I do the same thing here, 3.33 divided by 1.66, I know it's 2, but just doing it on my calculator to be sure is 2. And 6.7 divided by 1.66 is 4. So when you do this, you'll get something like 4.036. We're looking for close. So what's the empirical formula of this compound? In terms of whole numbers, we've got N2H4CO, because that's these whole numbers, N2H4C1O1, and that is our empirical formula. This last step, multiply till whole, only really applies if we have an empirical formula that isn't originally in whole numbers. Let's do a quick one. Here's one that is going to use this third step. So we've got 72.2% magnesium and 27.8% nitrogen by mass. What's the empirical formula? So the first thing we're going to do is assume 100 grams of our sample, and that instantly turns these from percents into masses. So that means we've got 72.2 grams of magnesium and 27.8 grams of nitrogen. Now that we have these into masses, we'll convert from mass to moles. So how many moles of magnesium do we have? If we have 72.2 grams, and the molar mass of magnesium is 24 grams. So taking our calculator, and magnesium's molar mass is 24.3, so rounding to a whole number is we're going to have to squish this in a little bit, but it works. This is 3 moles of magnesium. That worked out all right. And let's do the same thing with our nitrogen. How many moles of nitrogen do we have? This is 27.8 grams of nitrogen, and in 1 mole there are 14 grams, and so this is 1.98 moles of nitrogen. Okay, so we're going to multiply, we're going to divide everything by the smallest to get it into whole number ratios. And watch what happens when we do this. So we're going to divide both sides by 1.98. That gives us 1. And we're going to divide both sides by 1.98. And this is going to give us 1.49. We'll round it up to 2. So 1.5. Well, that's not a whole number. So the last thing that we're going to do is multiply until these are whole. And so we can multiply everything by 2, and that gets rid of this half. So our final step is to multiply everything until it's whole, and that's going to give us, if we have magnesium 1.5 and nitrogen 1, we'll multiply everything by 2. So our empirical formula is magnesium 3, nitrogen 2. Whoops. Mass is going on in the chapel. All right, let's move on to one that is going to show us the difference between empirical and molecular formula. So, if the empirical formula is the simplest whole number ratio of elements in a compound, then the molecular formula is the actual ratio. I'll give you an example. There are a number of carbohydrate compounds that you are probably familiar with. This one is called glucose, this one is called maltose, and I can't remember what this one is called, but you can probably figure it out. And these are all different formulas, but they all have the same empirical formula, the same simplest whole number ratio. So how do we get there? Let's take an example. So here's a question. It says caffeine has the following percent composition: 49.48% carbon, 5.19% hydrogen, 16.4% nitrogen, or oxygen, and 28.85% nitrogen. It has a molecular weight of 194.19 grams per mole. What is its molecular formula? So the first step is we're going to find the empirical formula, and that means we're going to use these 4 steps. So converting everything from percent to mass by assuming 100 grams, we get these masses of each of our elements. Our next step is to convert each of these into moles. So here are our moles of each compound. We're going to divide everybody by the smallest mole to get this into whole numbers. That makes this 1. That makes this 2. That makes this 4. And that makes this one somewhere around the neighborhood of 5. Let's use our calculator just to be sure. And it's 5. So what is our empirical formula for this compound? 4 carbons, 5 hydrogens, 1 oxygen, 2 nitrogens gives us C4H5ON2. But this is the empirical formula. The question is asking for the molecular formula. So obviously there's something different. How do we do this? We're going to look at something called empirical formula mass. I'm going to abbreviate this: empirical formula mass, EFM. We're simply going to add up the masses of each of these elements in this compound and see how it compares to our molecular mass. So we've got 4 carbons, 5 hydrogens, 1 oxygen, and 2 nitrogens. So looking up their molar masses on the periodic table and adding them up, we get, so the carbon is 12, there's 4 of them, the hydrogen's 1, there's 5 of them, the oxygen is 16, there's 1 of them, and the nitrogen is 14, and there's 2 of them, and adding them all up, we get an empirical formula mass of 97 grams. How does this compare to the molecular mass? It says right here it's got a molecular weight of 194.2. So what we're going to do is we're going to take the molar mass and we're going to divide this by the empirical formula mass to find the ratio. 194.2 grams divided by 97 grams. We get 194.2 divided by 97 is exactly 2. That means that the molecular formula is exactly twice the size of the empirical formula. So we're going to take everything that's in this compound and multiply it by 2. And so our empirical formula multiplied by 2 gives us the molecular formula C8H10O2N4. And that's all you do.